Okay, so we are continuing with our series of functions and relationships. It is going to relate very much to number patterns. Okay, so if you guys were here for number patterns, you will remember what we are going to do today. Excuse me, someone just DM'd me. So let me just attend to them. There we go. Okay, so if you guys remember, how did we find general formulae for number patterns? Does anybody remember? Does anybody remember? Obviously, it won't be for all of them, but let me ask about this: arithmetic or linear number patterns? Okay, thank you, Narisha. Good start. So we need to check if this is a linear number pattern, right? And we're going to do that by checking how do we get to the next term. Oh no, we're starting with black screens. Is anyone else's screen blank so that I can fix it quickly before we get into our lesson? Imra, I'm sorry about that. No, Leah says no. Imra, try logging out and back in. Ooh, okay, no, seems like it's a lot of people. So I'm gonna pause the recording. Cool, hi, hello. So we were checking, how do we get from one consecutive term to the next, right? The first thing I'm going to say is be careful. This table doesn't necessarily have consecutive terms. So look here. We go from term number -3 and suddenly we add -1, 0, 1. So we have to make sure we work out the common difference between terms that are next to each other. So that would be -1, 0, and 1. So we're going to use those three to see if we have a common difference. Okay, so to get from -1/3 to 0, how much am I adding? -1/3 to 0. How much am I adding or subtracting? I should say it like that. How much am I adding or subtracting? To get from -1/3 to 0, how much am I adding or subtracting? So I'm about to suggest we add 2/3. Okay, let's see. There we go. How much am I adding or subtracting to get from -1/3 to 0? Leah says you -1/3. So about to says I made a mistake. Come on, guys. There's 120 of us in here. I need way more answers than that. Okay, I see 2 people say add 1/3. Someone said add 1, -1/3. Okay, guys, add 1/3, right? Think of your number lines. If you're at -1/3 and you want to get to 0, you have to plus 1/3. And then to get from 0 to 1/3, how much am I adding? To get from 0 to 1/3, I'm still adding 1/3. So we do indeed have a common or constant difference, right? So now we have to figure out our general rule for this table. We're going to use that common difference as a multiplier. Who remembers what a multiplier is? I'm not using TN because we're not doing number patterns. Who remembers what a multiplier is? Nope, we all forgot. Anyone? Oh, I did something. Oh, there we go. We're back. Anyone remember what a multiplier is? Ropafatso clearly doesn't remember. He's like, what is that? Okay, what I meant is we are going to say y equals 1/3 times x. Now we want to check, do we have to add or subtract anything to get to our desired output? So multiply literally means it's the thing you're multiplying. I get 1/3 x. Of course, I'm going to say I get, sorry guys. 1/3 x means 1/3 times x. So that's what I mean when I say we're going to make it a multiplier. Now we have to test it with one of these, right? So let me say y equals 1/3 times 1. How much is a third times 1? We're checking with term number 1 here, with input number 1. I need to stop saying term. I won't confuse you guys. We're checking with input number 1. What is a third times 1? It's a third. Is that the output that we want? Check in the table. Is the third the output that we want? Remember, we inputted 1. Do we want an output of third? Yes. So do we have to modify this formula, or is it fine the way it is? It took us straight to what we wanted. Do we have to keep it, or do we have to modify it? Excuse me. It's fine. So we don't have to add or subtract anything. The only thing I would say is check it with a different term. Let's check it with 3. So y equals a third times 3. How much is a third times 3? A third times 3 is 1. Is that the output we're looking for? Yes, it is. And yes, you may divide it by 3. Okay, multiplying by a third and dividing by 3 is the same thing. So that would mean our formula is correct. Now that we have a formula, let us fill in the rest of our table. Okay, so if my input is 6, where do I substitute 6? Do I substitute it in my x or in my y? My input is 6. Kwezi, let's hear. Hi, Kwezi.
Hello, ma'am.
Hello. Do you have a question?
No, ma'am. Can I try to 6?
Beautiful.
Okay.
So where do I substitute it?
You substituted to the x.
There we go, because it's our input. So y is equal to?
Y is equals to a third times 6.
Mm-hmm.
And when we put that to our calculator, we get 2.
2. Beautiful. So when you input 6, your output is 2.
2.
Let's do 12.
Okay. Okay, so a third equals to 12. Oh, no, sorry, ma'am. A third times 12.
That is?
And then third 12. It's 4.
Oh, beautiful. Thank you, Kwezi, for helping me with those.
Welcome, ma'am.
Let's hear if Sia can help us with the next ones. Or does Sia have a question? Hi, Sia. Yes, we are.
Hello, ma'am. I'd like to answer the next one.
Okay, Sia, where do we substitute 5 and 2/3?
With 5 and 2/3, you have to substitute at y.
Beautiful. So it's going to be 5 and 2/3 equals
to 17.
Oh, you already worked it out. Oh, wait for me. It's a third x, right? Yes.
Huh?
There we go. And then I'm going to make this an improper fraction just because I'm using my brain. Okay. A third, 17/3 is equal to a third x. If you divide by 3 is the same as divide by a third is the same as timesing by 3/1. And these 3's cancel. Therefore, x is 17. Thank you, Sia, very much. That was beautiful. Did you do the next one? Nope. Sia has vanished. Sia has vanished. Emmanuel, let's hear what Emmanuel has to say. Okay, I'm gonna explain 17 just now. Yes,
hi, ma'am. Okay. Yes, ma'am. So we're gonna swap y with 25/3 equals 1/3x.
There we go. 25/3 equals a third x. Very nice.
Yes. And then we're going to say 25/3 times 3/1 equals 1 over 3 times 3 over 1 x, or we can just, leave 1 over 3 alone, equals, 25 equals x. That's gonna be our answer.
Thank you very much. X equals 25. That was beautiful. Thank you. So this is 25. Okay, let me explain the last two, 17 and 25. So guys, we got our rule, right? We figured out that our rule for this table is y is equal to 1 over 3x. Remember, y represents our output and x is our input. Now you have to look on your table, what did they give me? In this case, 5 2/3, which is over there, is your y, which is your output. So in your formula, you substitute 5 2/3 where you have y. Okay, so then you go there and you say 5 2/3 where the y is, okay, is equal to 1 over 3 times x. And then I simplified this by making it a improper fraction. 5 times 3 plus 2. That's where I got the 17 over 3 is equal to 1/3 x. Okay, now I want to get rid of this third that's in front of my x. Okay, this third is bothering me. So since it's 1/3 times x, what I did was I divided by 1/3. So I said 17 over 3 divided by 1 over 3. That will give me x, because these 1 over 3s will cancel out on the two sides, okay? But I changed this to a times, tip and times, so that I can cross cancel. Check here, times, and then 1 over 3 became 3 over 1. Now you can cross cancel. We have a 3 in the denominator here with 3 in the numerator, once. So it's going to be 17 times 1, which is 17 over 1. That's how I got to x equals 7. Okay. I hope I have sort of appealed to the people who sort of didn't understand. I see a lot of people can't see. I can't explain much if you can't see. Mamelo, do you have a question?
Yes, ma'am.
Let's hear.
Ma'am, can you please redo the last one? Because I got a different
Here's the
answer.
one that I just did.
Yes, ma'am, but the last one I got a different answer from yours.
Did you make the same? Did you use a calculator? Let me start there.
Yes, ma'am.
So you said 8 1/3 on your calculator.
No, I first made it into a proper fraction.
And then what did you get for an improper fraction?
25 over 3.
Beautiful. And then you're going to divide by 1 over 3 on both sides, right?
1 over 3 in both sides.
Divide by 1 over 3 on both sides. That's how you get rid of this times 1 over 3. Divide by 1 over 3, right?
Yes, ma'am.
And then we tip and times. Do you see that?
Oh.
So then the 3 in the denominator will cancel out with the 3 in the numerator. Do you see how we got 25?
Yes, ma'am.
So with your calculator, I'm not sure what could have happened. Tell me what you typed in your calculator.
So, ma'am, I say 25 over 3 times 1 over 3.
Oh, you forgot to tip and times.
Oh, yes, ma'am.
So it's times 3 over 1, not 1 over 3. Do you see?
Yes, ma'am.
There we go.
Thank you,
Let me
ma'am.
hear other questions. Okay, Nalasia. Nalasia sounds new. Hello, Nalasia. Or is it Alicia? Nalicia. Oh my goodness. Nalicia. Nala Alicia. There we go. Sorry. You muted yourself again. Sorry, Alicia. Hello.
Hello.
Hi.
Ma'am, I can't see anything. It's blank on my phone.
Okay, can you see the chat?
No.
Oh, okay, that's a problem. Simone is typing help on the chat right now for people who can't see. Did you try leaving and coming back into the meeting?
Yes, I did.
Okay, then I'm not sure what the problem might be. Try to access the chat and then someone will be able to help you, okay? Maybe you need to change
thank you.
views or zoom out. It's possible that you've zoomed in a lot. Try zooming out and then see if that helps.
Okay.
All right. Let's hear Fatima. Hi, Fatima.
Hi, ma'am.
Hello. Do you have
How
a
are you,
question?
ma'am?
I'm good, thank
Yes,
you.
ma'am. I'm fine, ma'am. Ma'am, I have the question about number 17. Like, I didn't understand how you got 17, ma'am.
Okay, do you understand where I substituted it? Do you understand why I have to put it where the Y is?
No, like, no, ma'am.
Okay, you have an
Like,
input and an output, right?
yes, ma'am.
The 5 and 2 over 3, is it by your input or your output? Look on the table. Is it on your X or on your Y?
Output, ma'am.
So do you see why we put it at the output?
Yes, ma'am. Yes, ma'am.
Yes. So you can't substitute it in X because X is your input. You see?
Put. Yes.
Beautiful. So that's
And
why.
we're looking for the input.
Yes, we're working backwards.
Mm.
So then I just made it an improper fraction. Okay. You're with me on
Yes,
that
ma'am.
part? And then
Yes,
to get
ma'am.
rid of a multiplication, what's the inverse of multiplication? What's the opposite of multiplication?
Division.
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 So if you had times 1 over 3, you have to divide 1 over 3 to get rid of it on both sides. You see?
Yes, ma'am.
And then to solve it, I tip and times. It was divide 1 over 3, so I made it times 3 over 1. You see?
Yes, ma'am.
And then the 3's cross cancel, so you're left with 17.
17. Okay. Yes, ma'am. Thank you, ma'am, for clarifying, ma'am.
You're welcome. Noko.
Hi, ma'am.
Hello.
Ma'am, can I please ask by the 17 over 3, how did you get the 1 over 3 x?
It was in your formula. Can you see our formula here? The
Oh,
highlighted
okay.
one that's highlighted.
Yes, ma'am.
So our formula was y equals 1 over 3x. So that's where we started.
Oh, okay, ma'am.
Beautiful.
That was my question. Thank you, ma'am.
You're welcome. Okay, guys, let's move on. Let's do this one. Is going to take forever. Let's do this one. Let's see. Follow the same steps. Let's follow the same steps and see if we can get to fill in the rest of my table. Okay, so we have -3, -2, -1, 0. At least these are consecutive numbers, which means they're right next to each other. Okay, so how do I get from 14 to 11? We first need to find our multiplier. We need to find that number that we're going to multiply with. So we find it by saying, how do I get from 14 to 11? Thank you, Sanda and Mamelo. We subtract 3. So you say -3. Manual, be careful. And from 11 to 8, there we go, Manual, beautiful. How do we get from 11 to 8? We subtract 3 again. Okay, so this is our multiplier, okay. So It's going to be y equals -3 times x. Let's test, what do we have to add or subtract to get our output? I want to test it with -3. If I say y is equal to -3 times -3, how much is that going to give me? How much is that going to give me? Yes! Move for my hazard. -3 times -3. It's going to give me a 9. Is 9 the output we want, guys? Look at our table. No. What do we have to do to 9 to get to the output we want? We want 14, right? So what do we have to do? Thank you. We have to add 5. So in our formula, it's -3x plus 5. Now let's test if it works. Let's test it with numbers on this side. Let's test it with 2. Y equals -3 times 2 plus 5. How much is that? What's -3 times 2 plus 5? I'll answer you just now, Mtokozisi. -3 times 2 plus 5. Guys, look carefully. -3 times 2 is -6. Plus 5, we're on a number line here. If we're at -6 and you're adding, you're going that way. It's going to be -5, -4, -3, -2, and -1. Okay, so the answer is -1. Is that our desired outcome? Is that the output we want? Yes, it is. So our formula is correct, right? I'm going to give you a few moments to screenshot this because I'm going to rub some of it out. Let me answer. I forgot who it was who asked, how do we know it's 5? So we know it's 5 because we used our common difference, which was -3. I think it was Ntogozisi.
Ma'am.
You're the one who asked, right?
Yes, ma'am.
Beautiful. Listen carefully. So we used our common difference, which was -3, né?
Yes, ma'am.
And you have to multiply it with the input. Okay. So we're doing a trial and error. So I did exactly that. I said -3 times the input of -3. So don't confuse these two, né?
Ma'am?
Okay, it's very noisy on your side. I'm just going to mute you so you can hear me. Okay, so we took our multiplier and we put it there because it's going to be your multiplier times your input. So let me highlight them in different colors. That 3 is that 3. It's the input. Okay, goes there. Whereas the 3 in front is the multiplier. Cool. So you have to do that and check your answer. If you multiply negative and -3, you're going to get a 9. But 9 is not the output we want. Our output that we desire is 14. So you have to check, how do I get from 9 to 14? And that's how we decided that you have to add 5. I hope Ntogozisi sort of gets where I'm coming from now. Tafara, let's hear what you have to say.
Ma'am, I don't understand how you got to 2 if the multiplier was 11, ma'am.
I'm not sure where are we talking about here? Are we talking about the last question I asked?
Yes, ma'am.
The multiplier doesn't change, okay? It's always -3. So we're using this formula over here. Do you see this one that says -3x plus 5?
Yeah.
-3x plus 5. So if I want to check the solution for 2, is this 2? Let me highlight it for you. I need you to tell me, is it my input or my output? Check in the table. There.
Input, ma'am.
It's your input. So am I going to substitute it where I have an X or where I have a Y?
An X.
x. So that's what we did, okay? So you're going to say -3 times 2 plus 5. Now we're going to integers. What's -3 times 2?
It's 6, ma'am.
Just 6. Negative and a positive, what do they give you?
-6, ma'am.
There we go. -6 plus 5. So in your number line, you have to start at -6. When you are adding, are you going to the right or to the left?
To the right, ma'am.
To the right. So we're starting here. How many times?
5 times.
5 times. 1, 2, 3, 4. Okay. 4, 5. Do you see how we got the answer of -1?
Yes, ma'am.
Was that your question? I hope I answered the correct question.
Thank you, ma'am.
You're welcome. Beautiful. Tammy, do you have a question or are you helping me with the next ones?
Hi, ma'am.
Hello.
Ma'am, I'd like to help you with the next one.
Okay, let's do it. Which one are you helping me with?
Ma'am, we can do -28.
-28. Okay, where am I substituting -28? Is it my input or my output?
Ma'am, it's your output.
It's your output. So where must I substitute it?
You're gonna say -28 equals to -3x plus 5.
Beautiful, Tammy. Plus 5. Okay, now what?
And then, ma'am, you're gonna put like terms together. So you're gonna say -28, and you're gonna transpose the 5 to the left. So you're gonna say -5 equals to -3x.
Beautiful. And then?
And then, ma'am, -28 minus 5 is equals to -33 equals to -3x. And then I'm going to divide both sides by -3 because once you be left with x and not -x.
Therefore, x is how much?
11, positive 11.
Beautiful, Tammy. That was brilliant. Thank you.
Clever, ma'am.
That was brilliant. I see there's more answers in the chat. Let's see who's going to help me with the next one. Palesa, do you have a question or do you want to help me?
Ma'am, I want to help you. We can do 5, ma'am.
5, okay.
So, ma'am, we're going to say -3a multiplied by 5, which is -15, plus 5, which is -10.
15 plus 5, which is -10, and you are brilliant because that is correct. Thank you very much.
Thank you, ma'am.
Thank you. Let's hear. Fatima, do you have a question?
No, ma'am, I want to help you, ma'am.
Beautiful.
With
which one?
8.
8. Okay,
8.
let's hear.
Yes. So, ma'am, you put it like this. It's y, and your formula. You write formula, right? Then you're gonna write -3 bracket open 8 bracket close plus 5. So you're gonna multiply -3 and 8, right? Which gives you 24. Then you add plus 5, which gives you -28.
What's -24 plus 5? Check again.
Wait, no, ma'am, 19. Sorry.
-19. Beautiful. Thank you, Fatima. You're getting it.
Thank you.
Whew, you guys are brilliant. Okay, I need to charge my laptop. So I'm going to give you guys 2 minutes while I charge my laptop to fill in. Okay, we filled in this is -19. I need my input for -37 and my output for 0. You literally have like 1 minute because I'm just charging my laptop. And I'm back. Let's see what we have to say. 37 is 40. Mamela says, can I please do the last one? Okay, let's see. Where's Mamela's hand? Mamela really wants to do the last one. Let's see what Mamela has to say for us. There we go. Yes, Mamela.
Yeah, ma'am.
Hello.
So, ma'am, what I said to my answer is I did negative 37 equals to negative 3x plus 5. Then I moved them into like terms. So I said 37 minus 5 equals to negative 3x. And then I subtracted the negative 37 minus 5 and I got negative 42. So I then divided the negative 42 by negative 3, and then on the other side I divided it by negative 3. Then my x is 14.
Beautiful, Mamelo. That was beautiful. Thank you.
Thank you, ma'am.
Wow. So have you noticed in this class, everyone skips the easy questions? I've actually noticed it happens really often. Like nobody wants to do the 0-1, and it's literally just substitution.
I have noticed that. I think they like the hard questions.
I think so, because most of the time everyone's like, nope, we're not going to do that one. Every time I ask someone, is like, I'm going to do the difficult one. I love it, guys. That's beautiful. I really love it. It happens often, Sofafaza. Have you seen? Okay, Ropafaza says, I want to do 0. Please do, because you guys are just like, everyone skipped it. We started with the difficult ones. Ropafaza? Hello.
Hello, ma'am.
Let's hear what we have.
Okay, so y equals negative 3.
Mm-hmm.
3 multiplied by 0
Mm-hmm.
plus 5.
Yes. Mm-hmm.
Okay, if y equals 0.
Mm-hmm.
Yes, ma'am, y equals 0
Plus
plus
5.
5.
There we go. And your final answer is?
5.
Thank you very much.
Mhm.
Woo, I think we deserve a brain break, guys. What do we say? I think we deserve a brain break. So I'm going to scroll down to brain breaks and then I'll take questions after that. When does 9 plus 5 equals 2? If you have a question, keep your hand up. If you wanted to answer, please lower your hand now so that I know that the hands that are up are questions. When does 9 plus 5 equal 2? Saneliso says never. Anyone else have a suggestion? Well, we all say never. Gonna laughing. Yes, on the clock, guys. On the clock. Who was that? That was beautiful. 9 o'clock plus 5 hours will give you 2 o'clock. Who was that? That was a beautiful. Or you can look at just like the 12 o'clock clock. The analog. I can't believe I just said 12 o'clock. Pretend that's a circle, guys. If you are at 9, which is there, this is 10, 11, 12, 1, 2. So if you start there, say 1, 2, 3, 4, 5. See? So it works with time. Nami, you're breaking us. Guys, I love you so much. You guys just don't see it. You guys just don't see it. Zukanye, beautiful Zukanye. Guys, I said brain break means your brain must break. Didn't I say that? Okay, let's go to the next one. Hi, K Coach. Over to you, my dear. You can do it digital as well. The most random things involve maths. Exactly, guys. Okay, if a boy is 2 years old, his brother is half as old as him. When the first boy is 100, how old will the brother be? This one is easy, guys. Tatas like actually have no words. No words for me, it's fine. 50, 50, 50, half of him. Guys, if the first one was 2 years and the younger brother was half, that means the younger brother was 1 year old. Eh? That means they're only 1 year apart, guys. So if the one is 100 years, the other one would be 99 years. Sorry. Bye, bye, Yamir. Bye, Yamir. Okay. Imposter can't see. How can says, yo, God help us. Guys, we're just having fun. Leabana says, I'm over this. That person will be 990,000 years old. I'm over it. They'll be 99, guys. I'm sure this is not legal. Let's do the last time. Let's do the last time. Let's do the last time. Okay. 2 mothers and 2 daughters each had 1 egg for breakfast, but they only ate 3 eggs altogether. How can this be? It is 99, Tato. Tato believes mom, but doesn't believe me. I can't believe. Even me, I can't believe. Guys, how can this be? If 2 mothers and 2 daughters had 1 egg, but only 3 eggs were eaten, how is this possible? Because it's only 3 people. It is only 3 people. Kanjani, they have the 3rd egg. Give this to Elon Musk. Others don't need eggs. Love it. Guys, your responses are beautiful. There we go. See, we got this one, guys. No, they didn't share an egg, guys, because it is grandma. Grand. English is like over to you. So it's grandma and child. Okay, so it is 2 moms and 2 daughters. Okay, because this one is a mom, but this one is also a mom, and this one is a daughter to this mom, but she's also a mom to this daughter, and this one is a daughter also to the mom. Leah, like, just go to Wimpy. I'm over this. Just go to Wimpy, guys. Wait, what? Chloe's like, what? Guys, the mom is a mom, but the mom is also a child. Guys, stop it. Okay, I'm done. I'm done with you guys. Let's hear if Annalisa has a question. Hi, Annalisa. Annalisa. Leano, someone says you just say mom a lot of times. I knew maths was evil. I'm done. Leano.
Hello, ma'am.
Hello.
I think it's 12.
What's 12?
The answer.
No, we already had the answer. We just had to figure out how it's possible that 2 mothers and 2 daughters had 3 eggs.
Oh.
Okay. So guys, the grand is mom, but the mom's also mom, and the mom is mom to child, and child is child to mom, who's also daughter to grandmom. Okay, let's move on. I think your brains are okay. I think your brains are okay. Someone called the department on me. Nice, okay. Okay. Now, Now, we are going to match these formulae and tables. Let me number the tables. Number 1, number 2, and number 3. So you're going to use substitution to check which formula matches with which table. Our brains are in hospital. Is visiting hours. Go visit and use it. Come on now, let's go. Okay, so I need you guys to tell me which table matches with which formula. Let's hear what everyone has to say. We have to use substitution. At least I gave you a clue. Your bed ate your pen. What a difficult. Please check in your hand. It could be in your hand. After the trauma you guys just went through, it's possible you're holding your pen in your hand. Okay, let's hear, guys. Any ideas? Remember, you need to use substitution. You have your calculators, guys. It's not that bad, okay? Just check, use an input and output. So you check, if I use an input of -1 with the first formula, will I get an output of 0.22222? If not, then it doesn't match. Then you check the other one. So it's trial and error. Sia looks like they have an answer for me. Yes, Sia.
I checked multiple times and I think A is B. A is number 3, ma'am.
A is number 3. Let's check. Okay? So you say A is number 3. So if I have, if I have x squared, let's try with 0. That's going to be 0 squared, which is 0, minus 2 times 0, which is 0 plus 4, which is 4. Okay, the first solution works. Let's check with something else. Let's check with 2. It's going to be x squared, which is 4, minus 4, plus 4. That's correct. So 3 would be A. Thank you very much, Sia. Thank you, Sia. That was nice. Let's hear if anyone else has a different solution. Palesa, have you figured out another one?
Ma'am, I think C is 1.
C is 1.
Yes.
Let's check. Okay, so C is y is equal to 2 times 3 to the power of, let's try it with 2. 2 minus 1 is 1, which is 6. Okay, 1 is correct. Y equals 2 times 3 minus 2 is 9, which is 80. That's correct. That's correct. Beautiful. Beautiful. So 1 is C. That means 2 has to be B. Let's check if 2 is B. So it's going to be y equals, I'm going to work with 1. It's going to be 2 to the power of 2 minus 2 plus 4, which is 2 squared. 4 minus 2 plus 4, which is 6, and that would be correct. I hope you guys were able to do this. Okay. I hope you guys were able to do this. Come on, guys, chat. Let's get back to the lesson. Let's keep a lesson in English. Let's keep the chat lesson related. There we go. Okay, let's do the same thing. Now, there's a little bit of a trick with this one, but it's a very small trick. Let's see if you guys were able to figure it out. So we're doing the same thing. You're going to tell me, is 1.1 table A, table B, table C, or table D? Let's hear what you guys have to say. Before we even go anywhere, does anyone see what the trick is? It's okay, hello? Does anyone know what the trick is? Okay, let's hear. What's the trick? Someone said yes. Let me see. Informal. Let's hear what Informal has to say. What's the trick in this one? Tammy, let's hear what Tammy has to say. Tammy?
Ma'am, is the trick that ma'am, at 1.2 it's 2x plus 3y equals to 6.
Okay, but what's the trick? What do we first have to do before we can figure it out, Tammy?
Ma'am, oh, ma'am, is it the
There's only one step that you have to figure it out. X and Y are unknown. Yes, they are, but there's a trick. We're still going to substitute, but before we substitute, there's something we need to do. Let me hear if Sia knows what we have to do. Sia.
Ma'am, I thought I'm planning on answering 1.1. I'm planning on answering 1.1.
Okay, you have an answer for 1.1.
1.1 is table D.
Table D is 1.1. Let's check. So 1.1 says y equals 2x plus 4. So y equals 2 times 2 plus 4 is indeed 8. Okay, let's try it with another one. Y equals 2 times 8 plus 4 is 16, 20. Okay, that is correct. So 1.1 is table D. Thank you. But I'm still stuck on my question. What do we first have to do before we know how to figure this out? And Tabise? Let's hear what Tabise says.
Ma'am, I think 1.2 is B.
You think 1.2 is B. How did you get it? How did you substitute? Let's hear.
Okay. So what I said was, right, since C, okay, right, sorry.
Oh, they went quiet. Someone said it. Mamela said, find the rule. Guys, how are you going to do it if your input and output are on the same side? I suggest you put it in standard form. So put it in a way that says y equals something so that you can compare your x's and y's. So for 1.2, what you're supposed to do is first get y on its own. So it's 2x plus 3y equals 6. You take this x over, you don't want it. So you're going to have 3y is equal to negative 2x plus 6. You don't want this 3, so you divide by 3. So then y is going to equal negative 2x plus 6 divided by 3. Then you substitute. Okay, then you substitute. I saw raise your hand for help. Alicia, let me see. Alicia, is your hand up? Oh, not yet. Raise your hand, Alicia. I'm going to help you just now. Just raise your hand so that I can see. Manuel, do you have an answer for me?
Oh, ma'am, for 1.2 I don't, ma'am, but 1.3 I do, ma'am.
Okay, let's hear what's your answer for 1.3.
Oh, 1.3 is equals to B, table B, ma'am.
B. Okay.
Yes.
Okay, I'm first going to put it in standard form to make my life easier. So it says x, y equals 12. Therefore, y will be equal to 12 divided by x. Now let's check. You said table B, right?
Yes, ma'am.
So if I substitute 1, it's going to be 12 over 1, which is indeed 12. If I substitute 4, it's going to be 12 over 4, which is indeed 3. And that is correct. So 1.3 is table B. Thank you very much. Thank you. 1.4 is equal to table A. Okay, you guys are saying 1.4 is equal to table A. Let me check. Okay, 1.4 says y equals x squared minus 1. So if you say negative 3 squared minus 1, negative 3 squared is 9. Subtract 1, that's 8. That will be correct. And if we do it with 11, it will be 11 squared minus 1, which is 121 minus 1, which is 120. That is correct. So 1.4 is table A, which means the last one has to be table C. Okay, guys, if you don't have questions, that will be the end of our lesson. I know a lot of us have questions. I will be staying on to answer your questions. But for everyone else, this is officially the end of our lesson. Thank you very, very, very much for being such awesome, fantastic students. You guys make me so excited to come every day. Okay, bye guys. All the best. Good night. Do the quiz if you're ready. Okay, if you feel like you first want to watch previous lessons and remind yourself how to do this, then don't do the quiz yet. Just make sure you do it before Tuesday. Okay, make sure you do it before Tuesday so that we can have you on the leaderboard and stuff. So bye guys. If you have a question, raise your hand now. I am staying behind. Simone, you may go, my dear darling. I will be staying behind with people who need me to clarify some few stuff with them. Oh, the quiz was posted up there, but all the buyers are like, there we go, there's a quiz. Itumeleng, let's hear. Bye guys. Hi, Itumeleng.
Ma'am, I wanted to ask on the first question that we did. When you said 5 and 2/3 and 17 on the improper fraction.
First question, okay, let me scroll up.
The first question that we did.
There we go.
Yes. Did you start by saying 5 times 3 and then we added by 2?
Yes.
Oh, okay.
That's how it
And
got
then
17.
on 25, how did you get 25?
We did the same thing. So we started with 8 and 1/3, right?
Yes, ma'am.
So you convert 8 and 1/3 into an improper fraction. So that's going to be 8 times 3 plus 1. Do you see? This thing keeps coming to the bottom. It's irritating, sorry. So we first converted it to a improper fraction.
Okay.
Just like we did the previous one. And that's going to be 25/3 equals 1/3x. Do you see that?
Yes, ma'am.
And then we did the same thing. We took 10 times.
Oh, okay. I can see. Thank you, ma'am.
You're welcome.